Welcome back, guys. I hope that you have seen yesterday's session. Let us quickly revise that session. We have started with different shapes in that. We have seen rectangle, ellipse, arc, polygon, polyline, and so on. We have also seen demo classes for those. And later we have started with event-driven programming. What is event-driven programming? Now, whenever we create GUI-based application, user interacts with that application. So user performs some task or user acts on the GUI. Now your application must react based on the action performed by the user. So we need to write a code which will be running in background and perform some task based on the user's input. So actually user is driving your application based on events, and that's why it is called event driven programming. We have seen one example here, demo fx event class, where we have created one text and two buttons. Two buttons are setting the alignment of the text actually, so align left and align right. Let's quickly go through that file. So we have one h box which contains a text. We have another h box which contains two buttons, and we add those two horizontal boxes in a border pen. We add that pen in a scene, we add that scene in a stage, and we show that stage. So that's the normal arrangement of the nodes. Then what we want is, when user clicks on button left, we want to align our text to the left side, and when user clicks on the button right, we actually want to align our text to the right side. Now if you want to align this text on a left or a right, we actually need to set the alignment of hbox 1, and that need to be performed when user clicks. So when user clicks on a button, it is actually the action event, and to register that action event, we need to write our object dot set on action method. So all events are performed by user, but whenever we want to react on that, we need to write a code somewhere in a method, and that method need to be executed based on the event. So actually we need to register those methods to a particular event, and those methods are defined in a class, and those classes are called handlers. So set on action is a method which is going to register our handler. So we need to define it somewhere. So we define it in align left class. This is a user defined class, and we instantiate that class here. So let's have a look at this align left class. Here I have defined that class align left. Now this is not a normal class, it is a handler class. So we need to implement event handler here. Now this event handler is an interface which is a generic interface. We need to define what kind of interface we want. So in Angular bracket we define action event, because we are performing action event on a button. Now this interface is having one abstract method handle, and that we need to implement here. So we are overriding that handle method, and it takes one parameter action event e object. Now this is the method which will be called whenever user performs action event. So here we can write our code. We can change the alignment of our hbox 1 to the left side or the right side. So what are we doing? Actually we are registering our handler using set on action method. Our handler is this class, and that class actually implements event handler interface, event handler interface has a method handle which will be called, and within that method we can perform whatever we want. So we set alignment to the left. Similarly, if user clicks on right button, we set another handler here which is align right. So we have align right class. It again implements event handler, has a handle method, and in that handle method we set alignment of our hbox1 to the right side. So because of this settings, these reasons, we can set alignment of our text to left or right. So let me run this code. If I click on align right button, then it is going to call a handle method of align right class. So if I click here, my text will be set to the right side, and if I click on this button align left, then it is going to call handle method from align left class. So that's the reason we have this effect. That is the normal event handling. Let me go back to the presentation slides now and continue with the next topic. Next topic we want to see is the inner classes. Look, inner classes we have already used in the same example, but you might not have noticed it. Let's go through the theory part first, and then we will understand why we need inner class or how to define inner classes. Inner classes is nothing but a nested class. You have a main class. Within your main class, you define inner class. Syntax is same. You have a class keyword and then your class name and curly bracket, define its members, properties and methods, and so on. So generally inner classes are useful for defining handler classes, like we have handled align left and align right. And normally we define inner classes to use it is used only by its outer class. So if none of the other classes are required to access inner classes, then we go for the inner structure. Now inner classes has few features also. So whenever you compile your code, inner class compilation will be done based on outer class, then $, and then inner class name. Dot class extension will be the compiled file, and so on. These are the features you may read. We will upload this presentation slide on your e-content today, so you can read this thoroughly. So let me go back to the code to explain where is the inner class. Look, these two are the inner classes because these two are within your main public class DemoFX event. Okay, so we have in this class we have start method, we have one class, we have second class, and we also have public method void main. So these two classes are inner class. For the outer class is the DemoFX event class. Okay, so that's inner class. Now these two classes we have used as a handler classes. So generally all the handler classes are defined as a inner classes, because handler classes are only referred in the main class. No other classes are going to use these handlers. So this is how we define inner classes. Now let me come back here. Yesterday I said I have hbox1 as a property of my DemoFX event. I'm not defining hbox1 within a start method. So let us understand why today. Look, we have text within hbox1. Okay, and when user clicks on a button, we are going to change the alignment of hbox1 actually. Now changing those alignments are happening in the handler classes. So if I define this hbox1 within start method, okay, then the scope and the lifespan of hbox1 will be only the start method. I will not be able to access it here in the different inner class. Because of that reason, what we do is we define this hbox1 as a member of outer class, which is demofx event. So when I define it here as a property of main class, this property is accessible within this entire class. So even an inner class can access that property here. So that's the only reason we are defining hbox1 as a property member of the outer class. Okay, so this is the example of inner classes. Let me go back to presentation slides and go through the next thing. Next is the anonymous inner class handlers. You can go through these slides, okay, you can read all these contents, but what I want is I will explain that thing directly in the code here. This is the inner class, and that inner class has its own name, which is align left. So if I want to have anonymous inner class, then need not to define as a separate class here and create instance of that separate class at this place. Instead of having this line, we can directly define that entire class here. So let us have an example of that. So I'm defining it here, anonymous inner class, and let's define anonymous inner class for only one button left right now. So I comment this line and I set it here. So instead of going for this one, what we can do is we can have this entire class. I'll copy this one and I will paste it here at this place. Okay. So definitely we need to instantiate this class, so new keyword or new statement will be there, but as we are defining anonymous, we need not to give it a name, so I need not to have a name here. Again, I'm not going to explicitly implement event handler, so I will directly create an instance of the event handler interface, which is anonymous right now, and I need to call, as I'm using new statement, I need to call constructor at this line. So that's the change. Okay, so we directly instantiate an interface. Look, definitely it is not possible to instantiate any interface using new statement, but this is possible because anonymously we are creating a class, and that class has a constructor, and that constructor implements the abstract method here. Okay, so this is it. This is how you can have anonymous class handlers. So similarly, if I want to go for second one, then what we need to do is, let us define it here. Sorry, comment it. What I'll do is I'll only copy this event handler. Okay, I'll comment this part and I will paste it at this place, and I will call the constructor of anonymous class, so simple brackets here, and save it. Right, so this is the example of having anonymous event handlers, and this is going inline. Instead of defining somewhere else and instantiating it here, we write everything inline at the same place. Let's run this code and check what is happening now. Output will be the same. You click on the align right, your text goes to right side. Click on align left, your text goes to left side. So that's the anonymous event handlers. Now alongside this one, I also want to explain lambda expressions. Now this is not there in your syllabus topics, but it is very useful whenever you are writing such kind of inner anonymous handlers. Okay, so I'll copy this entire code and I will paste it here because we want to make some changes. Let me comment this part. So I'm not doing any change in this code. I'll upload this entire file so you can have a look at these step by step changes. So we want to learn lambda expressions. Lambda expressions is very useful to compress our code. Now to make this example use lambda expression, what we do is we directly define this e here, okay, at this place e, then we write arrow, okay, arrow, and that e is nothing but this entire method. That's it. This is done. This is the lambda expression. Look how it actually compresses your code. With a single line you will be able to achieve this entire thing. Now this thing actually requires 6 lines, whereas this is completing in the 3 lines, and if you have it in a single line, then it is over it with single line. So this is lambda expression. Very useful, right? Now this is not there in your syllabus topic, but it is there in your textbook and very fruitful to cover here. So if I change this one as a lambda expression also, then what I do is I will delete this part, okay, then I will write e. Look, this e is a user defined thing, you can have anything there, but that e is going to be referenced whenever you want to have event referred within your handler. Okay, so this is how we can achieve the same thing. If I run this code again and check whether everything works properly or not, then it will work. Okay, and that is lambda expression. So in further examples, I'll be using this lambda expression to compress my code. Okay, let me save this code and back to the presentation. Next topic we want to cover is the mouse event. Now we are going to see mouse events and key events. Key is the keyboard. So let's have a look at events now. Mouse event, whenever you perform any action using mouse, so maybe you are going to click a button on your mouse, maybe left button, right button, or middle button, and so on. So which button has been clicked, if you want to identify that, then you can call get button method. Then even you can count the number of clicks, so you can check whether user has clicked single time or user has clicked double click or single click. So to have that, you can have get click count. Then you can also find the position of your cursor. Get x method will give you the mouse point position, x coordinate, within your source node. So it depends, if you are running this get x based on your scene, then it will have the top left corner of your scene as 0 0. Okay. Similarly, we have get y, then we have get scene x. So this directly defines a scene. Get x and get y, you can have pan also. or border pen you have hbox and so on. So that's the reference. Get scene x, get scene y will directly refer to your scene, as well as you have get screen x, get screen y, which refers to the top left corner of your entire screen. So we have three different references: entire screen of, or the window, which is a scene, or the inner panel, or the sub structure of my screen. Okay, so these are the different references you may have. And then there are few other methods which will only check while clicking on a mouse button if Alt button in a keyboard is pressed or not, Control button in a keyboard is pressed or not, Shift button in a keyboard is pressed or not, Meta button in a keyboard is pressed or not. So Meta button is generally placed in your keyboard just right side of a space bar. You may have Alt button on the right side of your space bar, and then you may have a Meta button. After Meta button you may have Control button. So that's a Meta button in a keyboard. Now these four methods will simply return a boolean, true or false, whether Alt, Control, Shift or Meta button is pressed or not at the time of clicking your mouse button. So these are the mouse events. Now your mouse event class has already few constants defined in it. So primary, secondary, middle, none are the constants, which actually defines primary is the left click, secondary is the right click, middle is the middle click, and none is the none buttons are clicked, and so you can use get button method to compare with this primary, secondary, middle or so, to check which button has been clicked. Let's have a look at the example for mouse event so you will understand more related to this one. Moving back to Eclipse, focusing on the different class now. Let us understand what we have in this class right now. So we have a bordered pen. Within that bordered pen we set few paddings on all four sides. Then we have one pen which is having a text. We have another pen which has two more text, empty right now because we are going to display few information there. So we have two different pen, text pen 1, text pen 2. We add those text pens in a bordered pen, center and bottom part. Okay, and then we show the entire thing. So let me run this code to just check what is there on the output. We will be having one text. So this is a text, and that is my text pen 1. Text pen 1 takes this much part. Okay, and in the bottom part we have two more text, but it is empty right now, so not shown here. And this is the normal structure. Okay, now what we want to achieve here is, first thing, when I click anywhere within my text pen 1 upper part, okay, when I click there, I want to check which button has been clicked and what is the position of my cursor. So what we do is, on text pen 1 we are going to set on mouse clicked event. So let me uncomment this part. So what we do here is, we are going to register our event listener with the mouse clicked event. So on my text pen 1 I set on mouse clicked event, and I'm using lambda, not structure. So I directly define a method here, and within that method what I do is, I set my text 2, which was empty earlier. Okay, so I set a text within text 2, and there I'm going to have position of my cursor using get x, get scene x, and get screen X methods. Similarly, get Y, get scene Y, and get screen Y method. Now whenever we access these methods, we actually need to have the event object E. So we are using this E to call these methods: e.getX, e.getSceneX, e.getScreenX, and so on. And I'm preparing my string, that's it. I'm appending everything. So I prepare a single text and we set that text here. Similarly, using E, I'm also getting a button, e.get button. So if that button is a primary button, I will display a text left button was pressed. If it is a secondary button, then I'll say it was right button. If it is a middle button, then I simply say a middle button was pressed. Now all these constants, primary, secondary, middle, are there in the mouse button class. We need to import this one at the top. Okay, so let me save this code and run this again. So if I click anywhere in this part, that is going to trigger this set mouse clicked event, and whenever this is going to trigger this one, this code is going to be run, and that will take the position of X, set text 2. It will also check which button has been clicked, and it will set text 3. So let me click once here. So I click it and we have the position as well as which button was pressed message. So it was a left button, and within my pen it was at 265 and 60 position. Within my scene it was 295 and 90 position. There is a 30 pixel difference here because of having 30 pixel padding in the scene. And with reference to entire screen, it was 924 pixel and 260 pixel. So if I click somewhere else, this is going to change. This is going to change. Always I am clicking a left button. Okay, now let me click right button. So below you have a different message now. Right button was clicked. Anywhere you are clicking, so that's the right button. If I click a middle button, then it is going to give me the message middle button clicked. Anyway, it is clicking a mouse button, so every time my position is also displayed, right? So that is just to check when you click your mouse, what is the position, which button was clicked. Similarly, even you can drag your text. So if I want to drag a text, so my text 1, I'm going to set on mouse dragged. So whenever I drag that text, I'm going to change the position of my text. So what I'll do is I'll change the set X and set Y property. I'm going to call those methods X and Y property of the text, and we will set those X and Y property to the current X and Y property of our cursor, which we can have through E event object. Okay, so text1.setX will be set to the e.getX. Cursor X position will be set to text X position. Let me save and run this code. So if I click anywhere here, okay, it is going to give me the message which button and clicked and what is the position. Also, if I drag this text, okay, then I will be able to drag that text here. Look, when I'm dragging, I have continuously clicked my button of mouse. That is the drag event. Okay, and when I release, it will place that text there. So that is the drag. Fine. Let me close this output screen, and this is the example of mouse events. Going back to presentation, next is the key events, keyboard events we want to see. So key events are nothing but whenever you press any key in your keyboard, it is going to trigger key event. So when user clicks any button on a keyboard, if you want to check what that key was or what is a letter or anything else, then you can call these methods. Get character method will give you the string corresponding to the key pressed. Get code method will give you the key code. We will see what are the key codes next. Then get text will again give you the string describing the key code. Okay, we will see what is the key code next. Okay, let's go through the methods first. Then there are few methods like mouse methods, whether at the time of pressing a key Alt key was down or not, Control key was down or not, Shift key was down or not, and so on. And this will simply return a Boolean data, true or false. Okay, so let's have a look at the key codes. Your home key has a constant HOME. Look in this table, blue color, first column is the constant, and the right side it describes. So your home key has a home constant, end key has a end constant, page up key has a page underscore up constant, and so on. So these are the constants: left, right, up, down, escape, tab, control, shift, backspace, caps lock, and all constants. And these constants are key codes actually. And these key codes are defined in key code class. So if you want to use these key codes, import that class, and you can have event key code using get code method. Fine, we will be using these codes in the example, so it will be more clear at that time. So you have different methods: get code, get text, get character. So at what time which method will be proper to use? This slide simply explains it. If key is pressed or key is released, then you can have get code. It is going to return a code from that table. Get text will return a string for a key pressed, but get character will return nothing. It will return simple and empty string. But get character is useful when key is typed. So when you type a key, type event is nothing but pressing and releasing both at the same time. So you press and release, and this sequence of pressing and releasing will lead to the typed event. So when you type a key, you can use get code, but that will be undefined. So at that time, get character method will be useful because it returns a Unicode character or the sequence of characters, because you may press multiple keys. So it will return a sequence of characters associated with the key typed at that time. Okay, so let's have a look at the key events example. We have that here. We will first understand what is the structure of our screen. So we have pan. Within that pan we have one text, simple A, nothing else. We add that text in a pen, we add that pen in a scene, that scene is added to primary stage is displayed. Okay, so let me run this code, and on the screen we will be having only one letter A here. So that's it, closing that window. Now what we want is, on this text which is here, I'm going to set my key events. So set on key pressed event. I'm using key pressed event. Lambda notification, so directly defining a method here. Now in that method I'm going to write a switch case because I want to check which key has been pressed. So I'm going to write a switch case on key code. So I can have a key code from this event e dot get code will return a key code. So I will compare this key code with different cases. Okay, so we compare it with down, up, left or right arrow keys. Now if any of these keys are pressed, actually we are going to change the position of our text. So text x and y properties, and what we do is we simply add or subtract number of pixels, 10 pixels here. So whatever is the current position, we are going to either add or subtract 10 pixels and then break that case. So what this will do is, if I press down key, it is going to shift my text downward. If I press up key, it is going to shift my text upward, left side, right side and so on. So these lines are going to change the position of my text. If I press shift, then I say do nothing, so simply break it. And the default one, so if nothing from these cases, then what I do is, if another key is pressed, then I will simply check get text will give me the string. From that string I will pick first character and I check whether that character is letter or a digit or not. If it is a letter or a digit, then I'm going to set that text in the text which is being displayed. Okay, so that's what I want to do here. So I'll save this code, run it. We have this output. Okay, now let me press down key once, so 10 pixel down. Now if I click down key multiple times, then every time 10 pixel my text is being shifted. If I click on right side now, right arrow key, then 10 pixel on the right side, my text is shifted. So arrow keys are working properly, up, right, down, left and so on. And if I press any other key, let's say letter key H, then it will change the text here, H, G, F, D, A or whatever. And if I press shift and H, now shift will be simply discarded, but shift H prints a caps character, so capital H here, and arrow keys. Okay, so these are the key events we are handling. Let me close this output and back to the presentation. So we have seen mouse events and key events. Next topic is listener to observable objects. Look, observable objects are nothing but generally whenever we bind any property, then those binding properties are actually the observable instances. Okay, so those properties, if those properties are being changed, and whenever that property is changed, if you want to call some method, if you want to perform something, you can have this listener. Now in that case, what you can do is you can add a listener. So all those observable properties has a method add listener, and this method requires one object listener. Okay, and that is invalidation listener class. Invalidation listener has one abstract method which is invalidated, and that invalidated method will be called whenever that property is changed. We will directly go to the example for this one, so it will be more clear. Coming back here, so this is the same example that we have started with. Let me run the code. We have one circle in the center part, and to keep this circle in the center part, what I do is I bind circle center with width and height of my pen. Okay, this is what the result is right now. So let me close this one. We have one pen, we have one circle with radius 50, and now what we do is we bind the center X and center Y property with the width and height of my pen. Okay, it is having blue color stroke, red color fill color, and so on. And then there is a text which is empty right now. We add that circle and text in the pen and we show everything on the screen. That's it. Now what I want to do is, let's say if I resize my screen, then I want to have a message where it says what is the center of my circle. So when I resize my pen, okay, then its width and height is being changed. So that's where we bind, or that's where we add a listener. So whenever width property is being changed of my pen, I will add a listener here. Now this is anonymous event handler, fine. So we directly create a new instance of invalidation listener constructor, and in that what we do is we implement invalidated method. Now this method will be called whenever width property is changed of my pen. So within this method I can write whatever text I want, or I can write a code for whatever task I want to perform. What I want is I want to simply set this text. So I am going to set that text with some values, and these values are nothing but the calculating the center property using this line. So we simply do that pen width property divide by 2, and that will be the property value. We convert it to double value so that we can have it in the string. Similarly, we calculate the height, divide by 2 and access the double value. Now this will be executed when width is changed. So I need to write same kind of code if height is changed. So that's the simple copy and paste, changing the height property, adding a listener, and so on. So I set this one, save, run the code. Okay, so right now my circle center is at 100 position because my pen size is 200, and that's why we have 100 here. Now if I only change the width, then I'm going to change X position. Okay, Y position is 100 fixed. If I change the height, then Y position is being changed, X is constant, right? And if I change both, then I'm going to have that effect, X and Y both. And that is the listener. Whenever I'm changing any property, it is continuously listening to that, being calculated positions, and those positions are displayed here. So that is the observable property listeners. Back to presentation. So till now everything was related to listeners, events, handling those events, and so. Now this is the last topic of our unit, which is the animation. You can have some kind of animations here in the Java FX. So to have those animations, we have inbuilt animation class. It's an abstract class, have few methods and properties. So let's have a look at what are the properties and methods in abstract animation class. You have auto reverse property, which is a Boolean property. By default it is false, but you can make it true if you want to reverse your animation once it is completed one time, then second cycle will be in the reverse manner. Then there is cycle count, so it is integer property. What are the number of cycles you want to have this animation? Okay, maybe 2 cycle, 3 cycle, and so on. Then there is a rate property, that's a double property. Rate is a ratio, so 1 is by default, that's a normal rate. If you make it 2, then speed of your animation will be increased. So 2 rate, 3 is the number of 3 times speed will be there. So it is defining a speed of your animation. Look, it is not a duration, it is a speed. Okay. Then there is a status property. It simply says what is the current status of your animation, whether it is running or paused or done or what. It is a read-only property. Then there are a few methods: pause method, play method, stop method, and then the getter and setter methods for all those properties. So play, pause and stop will simply perform those animation. It will play that animation, pause that animation, or stop that animation. We will be using this play pause based on the mouse events. So if you click your mouse button, it will pause. When you release your mouse button, it will again play, and so on. Okay. So animation class is the abstract class. Need to have few implementation of such kind of methods there whenever we use it. So many concrete class has been defined based on this animation class also, and examples are path animation, fade animation, parallel animation, and so on. So these are the 2 animation classes which we will be looking at right now in your syllabus. So let's start with the path animation. Now before path animation, let us define duration, because with this duration we are going to define a duration of our entire animation. So we will be using duration class. Duration class is nothing but defining a duration for any animation, and it allows us to have some kind of mathematical operations, converting that duration into hours, minutes, seconds, and so on. And it will also allow us to compare 2 duration, whether those 2 are equal or not. And if it also allows us to define infinite duration, or 1 millisecond duration, or 0, or and something, right? This is immutable class. So once you create an instance, you cannot change it. So that is the duration class. Let us start with the path animation. The path animation is a class actually which allows us, or which helps us to create an animation which is based on a path. So we will animate a node which will create an animation along a path. We also need to define a path there. So we define a path, we give a node, and that node will traverse that path. So to do that, what we need is, we need a duration. What is the duration for my animation? We need a node which will be traversing the path. We need a path, obviously, and we need to have the orientation. Now this orientation, we will look what is the difference between 2 different orientations later. These are the properties, and then these are the constructors for path animation. One is the default constructor, no argument constructor, which creates empty path transition. Okay. Then there is a constructor with 2 parameter, duration and a path, or you may go for duration, path, and node, all 3 required properties. There are getter and setter methods also. Path transition, let us have it in effect. Okay, so let us understand what we have first. We have a pen. In that pen we have one rectangle at 0, 0 position, 25 pixel width and 50 pixel height, green color. Then we have a circle. Center position is 125, 125, radius is 50. It is white color filled and black color stroke. We add our circle and rectangle both in the screen. So let me save this code, run it once to just have a look at what we have. So we have one rectangle at 0 0 position, 25 pixel width and 50 pixel height, and we have a circle in the center position, 125 125 center with 50 pixel radius. Let me close this one now. Now we want to set path transition. Let me uncomment this code. How we have that? So we create an instance of path transition. Now if I'm not passing any argument to constructor, then definitely I need to set duration, path and a node which are required. So we set duration with duration class milliseconds 4000. So it is going to set 4-second duration for my animation. I'm setting this circle as a path. Okay, so this circle will become a path, and I'm setting node to this rectangle as a node. So this rectangle will become a node, circle will become a path. So what will happen is this rectangle will traverse my circle, and that traversal will happen in 4-second duration. Let me save. Now once I am done with this one, I will play my animation. So pt.play. Now this will play the animation. Let me save and run the code and have a look at the output. So my rectangle is traversing my circle once only. Okay, it is traversing that path once, one cycle, and that duration is being completed in 4 seconds. Let me close this one. Now let us have a look at the orientation. Let me run the code again and focus on the rectangle. Rectangle stays vertical, so this orientation is none by default. Now if I set orientation to the tangent, orthogonal to tangent, and this is the orientation coming from the path transition class. Okay, so if I do that, then have a look at the rectangle. This is what happens. So my rectangle will be at 90 degree always to my circle. That's what happens with the orientation. And now if I just want to have this animation to run infinite time, then I can go for set cycle count to infinite. Indefinite is the constant to have infinite time, and it is coming from timeline class. Even we can set auto reverse. So one cycle is over, then second cycle will be the reverse one. Okay, so let me save and run. It is going to traverse my circle and will come back from that path, and this will happen for infinite time. Now every transition takes 4 seconds, and this is continuous. I can increase the speed. Okay, if I don't want to decrease the duration, let's say duration is 4 seconds, but I can increase the rate of that 4 seconds. So set rate twice. So I am defining my duration to 4 seconds, but when I increase the rate of twice, then this 4 seconds will become 2 seconds actually, because speed is increased. So let me run the code. So within 2 seconds it will complete that animation. Okay, so we have seen play method. Now we can also go for mouse click events. We have seen already. So if I click on my circle with a mouse key, then what I want is I just want to pause or play my animation. So if mouse is pressed, I pause it. When mouse is released, I again play it. So let me save, run the code, and have the effect. Right now animation is continuous. When I press a key on mouse, then that animation is paused. I'm clicking my mouse button continuous, and when I release it, it will start animation again. Okay, so this is how you can handle your animations based on events. That is what the path transition animation is. Second, we want to see is the fade animation. Fade, so you fade out, fade in your object. Again, this is the animation, so it will have its duration, it will have its node, which node you want to fade in, fade out. Now from where fade, what fade value you want to start, so from value and to value, and what will be the step value. So by value is the step value, increment or decrement steps, and so on. Even it has constructors, fade animation, no argument constructor, then one constructor with duration, another constructor with the duration and node both. It has getter and setter methods also. So let's have a look at this example. In the same class, I'm fading in or fading out my rectangle here. So what I do is I create fade transition object. I will set duration to 2 seconds. Okay, and I will also pass the node, which is rectangle. So my rectangle will fade in and fade out in 2 seconds. The from value is 1, which means full color I am looking at, and to value is 0.1. 0.0 will be the totally fade out, cannot see it. So 0.1 we will slightly have that green color. Then the cycle count, I want to make it infinite, so timeline dot indefinite. I will also auto reverse true, so fade out, then reverse is fade in, and I will play it simply. So let me save and run this code. My rectangle will be fading out and fading in. Indefinite time, fading out, fading in, fading out, fading in, and so on. So that is fade in, fade out example. Okay, so that's what the animation classes are, and that's actually the end of this unit also. Look, I'm going to upload this presentation slide today, and I'm going to upload all these event examples and animation examples on the e-content. You download those, read the presentation slides, go through the book, and download these codes, play with the code, run it to understand. Thank you for joining.